So, good afternoon, everyone. I am Dr. Satyabrata, MDDM clinical pharmacologist, and today I am going to discuss on mass spectrometry. So, coming to introduction, mass spectrometry, is an analytical technique, and it is used to quantify known materials to identify unknown compounds within a sample and to elucidate the structure and chemical properties of different molecules. So what is the basic principles? The basic principle is that a mass spectrometer generates multiple ions from the sample under investigation and separates them according to the specific mass to charge ratio m by z. Then records the relative abundance of each ion type. So coming to the types of mass spectrometry, there are various types of mass spectrometry like AMS, that is accelerator mass spectrometry, gas chromatography, mass spectrometry, liquid chromatography mass spectrometry, isotope ratio mass spectrometry IRMS, ion mobility spectrometry mass spectrometry, MALDI-TOF, that is matrix assisted laser desorption ionization, CELDI-TOF, that is surface enhanced laser desorption ionization, tandem mass spectrometry, TIMS, that is thermal ionization mass spectrometry, SSMS, that is spark source mass spectrometry. So these are the various types of mass spectrometry. You can see the image of mass spectrometry on the right side, and then coming to the components of mass spectrometry. Three major components are there in mass spectrometry. Like one is ion source. Ion source is required for producing gaseous ions from the substance being studied. Then analyzer used to resolve the ions according to their mass to charge ratio. And another is detector system that will detect the ions and record the relative abundance of each of the resolved ionic species. And high vacuum is maintained in mass spectrometry. Then you can see the image here. Inlet is there, sample introduction, source, gas phase ions, vacuum pumps, analyzer, ion sorting, ion detector, ion detection nodule, and data system, and the data output, that is the data of mass spectrum on the computer. So these are the components of mass spectrometry. Coming to overview of mass spectrometry, there are four key stages in the process for mass spectrometry. One is ionization. You can see all this in the image right side, that is ionization. After that there will be a probe and sample collected, and there is accelerator plate, and ion beam is introduced, and slits are there, and there is acceleration phase, accelerator is there. Then another phase, it enter into the magnet. Then there will be flight, in the flight tube it will cross, and there will be deflection, uh, and only ions of the right mass can enter the detector. Then the detector slits in, enter into the detector slits the sample, and then the detector will record the uh, mass spectrometry finding. And there are four key stages like ionization, acceleration, deflection, and detection. So uh, you can uh, find out more about this from the articles and the books to gain more and more knowledge about it. Then this is the picture showing the inject sample, heater to vaporize sample, and electron beam ionization, then charged particle beam. And in the detector there will be detection, and yeah, before this magnetic field separates particles based on mass oblique charge ratio. So this is the picture of process how the mass spectrometry occurs, works. Okay. Then stage 1, ionization. Electroionization. Tungsten is the most common type of ionization. used in this mass spectrometry. The sample is bombarded by electrons which come from a heated filament. The electrons run in a stream between the cathode and anode. You can see in the right side image the same written here. When the sample passes through the electron stream, the high energy electrons in the stream knock electrons out of the sample to form positive ions. So the vaporized sample will enter and electrically heater metal coil is there. Then ion repeller, positive ions, electrons, electron trap shown in the picture. This is the stage 1, that is ionization. And then stage 2, acceleration. Here the ions are placed between a set of charges parallel plates, and the ions will then be repelled by one plate and attracted to the other. And there is a slit cut in the plate which the ions are attracted to. The force of attraction and repulsion which forces the ions through the slit at an accelerated rate. And the speed of acceleration can be adjusted by changing the charge on the plates. So the right side image will show the ionization chamber at plus 10,000 volts, ion beams, and intermediate plate and final plate at 0 volts. So this is the stage of acceleration. Then coming to the stage 3, that is deflection. Ions are deflected by the magnetic field surrounding the instrument, and the amount of deflection depends on the mass and charge of the ions. The heavier ions and ions with a positive charge of 2 or more are deflected at the least ion stream C given in the image, and the lightest ions and ions with 1 positive charge are deflected the most, ion stream A. And the ions that feel a magnetic force that is equal and opposite to the electric force travel to the detector straight, ion stream B. And the mass to charge ratio m by z is determined from the ion that hits the detector. So you can see at the right side image and correlate with the writing. So that mixed ion stream is there, ion stream A, ion stream B, ion stream C, and there is electromagnet shown in the image. So this is the stage of deflection. Then stage 4 is detection. When the ion stream reaches the detector, then hit a wire. On hitting the wire, they become neutralized by an electron jumping from the metal wire to the ion. The amplifier picks up on this current being created between the wire and the ion and amplifies the signal being detected. Then the computer picks up on this and converts it to mass oblique charge ratio, and a spectrum is produced. So in the right side image you can see the same. There is a metal box and stream where to amplify positive ion electrons. So this is the stage of detection. Then detectors. Ion detectors are divided into 4 classes. One is point ion collectors, that count ions of a single mass at a time. Another is array collectors, that is photographic plates, count multiple masses and detect the arrival of all ions simultaneously along a plane. Then Faraday cuff, another multi-channel plate. So you can go through the different books and articles to learn more about this type of mass spectrometry. And this is a picture showing the flow of vaporized sample particle and electron stream, ionized sample particles, acceleration field, ion accelerator, condensation plate, there deflector magnet is there, and photography film and stream of deflected ions. So this is also the process of deflection. So there are lots of software for like liquid chromatography mass spectrometry, gas chromatography mass spectrometry, uh, and IRMS and ICP-MS. That is, there are lots of software, and the process is ions detector, signal amplifier, and start input timing control, analogic to digital converter, integrating transient record ITR, adder, summing memory and data system. The time and intensity was given, and in the right side there will be the mass spectrometry finding, and the recorder, that is given that methyl group in the left side, CH2OH plus in the middle, and CH3 plus CHOH plus the right. So it is according to the mass charge ratio. According to the mass charge ratio, the sample will be separated in mass spectrometry. So you can go through different articles and books to learn more about LCMS, GCMS, IRMS, and ICP-MS, etc. So then coming to applications of mass spectrometry can be coupled with other techniques such as HPLC, high performance liquid chromatography, and gas chromatography, and it can identify compounds from all areas of science. And some of its uses are it can be used in stress gas analysis or pharmaceutical industry and space exploration, and also it can be used in forensic toxicology and archaeological dating. So this picture shows right side HPLC column and mass spectrometry coupled, and there is HPLC solvent containing dissolved analyte molecules, metal, coated gas, capillary, atmospheric pressure, vacuum, solvents, droplets from which analyte ions are released, 3500 volt different potential difference, ions and mass spectrometer. So this is the example of HPLC and mass spectrometer coupled um, uh, system. So you can go through different articles and books to learn more about the mass spectrometry and its uses. So these are my references. So you should know more about this topic by looking into the articles and books on mass spectrometry, and you can go through also search from different sites to authentic sites to learn more about mass spectrometry. So mass spectrometry is a very huge topic, so you can go through different materials to learn more about mass spectrometry. um, please please completely watch my videos and share and like and subscribe the channel so that you can be able to know a lots of things about different topics, and also I'm telling you that you should go through different books and articles to learn more about uh, this topic, and you can also comment in the comment box, questions in the comment box, so that there will be a there can be some discussion on this topic also. So that's all for today, and we'll meet again on another day. So thank you very much. Jai Jagannath.